Assalamualaikum and a very good day to everyone. My name is Mimi Suliza binti Muhammad and I am from University Tun Hussein of Malaysia. Today I'm going to present on my research topic, which is combined effects of banana peels and pith as dual natural plant-based coagulant for turbidity removal. Okay, coagulation process is a physical chemical process that are commonly utilized in the water treatment process. It is the process where we want to reduce the turbidity and also the suspended solid in the water. So the commonly used coagulant in the water treatment is alum, okay, which is a chemical coagulant. So in this study, we focus on the natural plant-based coagulant, which is banana peels and pith, where we combine this both coagulant because we want to know what is the dual effect of this coagulant toward the water treatment process. Okay, so the water sampling was conducted at the Muar River Johor, which is at the jetty of Pekan Panchor. So at there we collect the water sample manually by grab sampling in HDPE bottles. After that, we characterize the water for some water quality parameters such as pH, turbidity, COD, BOD, TSS, ammonia nitrogen, etc. Okay, for the methodology, first we prepare the banana peels powder solution, or we call that as BPPS coagulant. Initially, the banana peels were washed to remove any dirt on the peels. And then the peels were oven dried at 80 degrees C for 24 hours. Okay, after that, the dried peels were grinded into a powder form, okay, and then followed by sieving . And then the obtained banana peels powder, okay, BPP, was stirred for 1 hour in 100 ml of distilled water. After that, the mixture was filtered using a filter paper in order to obtain a solution where we call that as a banana peels solution, banana peels powder solution. Okay, next is the preparation of the banana pith juice or BPJ coagulant. Okay, so initially the pith was removed from the stem of the banana plant and then separated from the foliage. And then the piece was chopped to smaller pieces . And then about 100 gram of the pith was blended in order to obtain the banana pith juice or the BPJ solution coagulant. Okay, after we have obtained both type of coagulant, we've conducted a jar test experiment in order to evaluate the performance of both coagulant in water treatment process. So in this jar test, we have 6 beakers or jar with one control. Okay, and then the coagulant dosage is varied for 6 of the jar. And also the ratio between the BPPS and BPJ also we varied, and pH also with mixing speed. Okay, we have a variation of rapid mixing speed and slow mixing speed because we want to see the effect of this mixing speed toward the removal, okay, the removal of some water quality parameters. Okay, now we have come to the result. Figure 1 shows the surface morphology of A and B, the banana pith, and C and D, the banana peels powder. Okay, so based on this figure, we can see that the banana pith has a multicellular fiber and fibril, as well as a scaly cellular surface structure. Okay, and then each fiber also displays a bundle structure and lumen in the cross section of the raw fiber, in which each lumen consists of several fibrils. And then in figure 1, C and D, okay, we see that the morphology of the banana peel showing the coagulant having irregular shapes and porous structure. So this irregular shape and surface, it's actually exhibit a rough, micro rough texture with crate-like pores that also promote better adherence of contaminant. Okay, next is the result for the EDX analysis of the banana pith and peels coagulant composition. So based on table 1, we can see that the majority element found in the banana pith and peels powder were oxygen, carbon, and potassium. But other elements such as chloride and aluminium inside the powder were also observed. And then the existence of this element was also similar to the banana peels and pith as reported by other studies. Okay, next is the result for FTIR spectra of BPJ and BPPS coagulant. So based in figure 2, we can see that there is a strong peak due to the OH stretching at the frequency of 3263 and 3255. So this similar functional group was also observed by other study for banana peel where they detect this peak for OH and CO functional group. And then it is also indicated the existence of free hydroxy group of polymeric compounds such as lignin or pectin that contain the functional group of alcohols, phenols, and also carboxylic acid. And then the stretching bands around 1000, 1645 in BPPS and BPJ is ascribed to a symmetric stretching of the carboxylic COO negative double bond of deprotonated carboxylic functional group. And then the deprotonated carboxylic become negatively charged, thus increases the availability of the binding sites for positively charged compound. And then the wave number of 579 and 525 in the BPPS and also BPJ respectively were contributed by the CI stretching, aliphatic iodo compounds. And then there is also the presence of a few peaks, that could be attributed due to other compounds such as ester, polysaccharide, and also protein in the coagulant. Okay, next is the result of the effect of coagulant dosage toward turbidity removal. So as can be seen in figure 3, the optimum coagulant dosage for BPPS, BPJ, and then BPPS plus BPJ was observed at 60, 80, and then 20 to 20 ratio milligram per liter of the coagulant dosage. Okay, so for 60 and then 80 and then 20 to 20, the remaining turbidity is 31, 23.3, and then 31.2 NTU. Okay, so from the experiment, we can see that only little fine flocks will form and settle at the bottom of the beaker. Yet more visible particles can be seen suspended in the water sample after it settled for 20 minutes. And then the effect of coagulant dosage with no pH adjustment in the BPPS, BPJ, and then BPPS plus BPJ samples have very little improvement in the turbidity removal, with the reduction of 24.2, 54.6, and 20.6% only, respectively at the optimal dosage. However, the fact that the residual turbidity did not decrease further at the higher BPPS and BPJ concentration, that was not expected. Okay, so this might be attributed to the high charge density, of the coagulant, whereas smaller dosage are adequate for disruption of suspended particles, and then larger one can cause interference. Okay, next is the result of the effect of pH toward turbidity removal. So in figure 4, we can see that the effects of pH shows turbidity reduction in water sample to be greatest at pH 2 and 4. And then the significant effectiveness of BPPS with the experimental dosage of 60 mg per liter, BPJ with 80 mg per liter, and then BPPS plus BPJ at 20 to 20 ratio of milligram per liter under the effect of pH showed the obvious flock formation, and then the water appeared very clear. So the result revealed that the optimum pH for achieving high efficiency reduction of turbidity by BPPS was at 93.4%, at pH 2, and then 92.8% at pH 4, and then for BPJ is 91.7% at pH 2, and then 90.5% at pH 4. as well as the BPPS plus BPJ, which is 92.3% at pH 2. So the significant effectiveness of banana peels at acidic pH, it can be associated by the protonation of the functional group, okay, such as the amino and carboxyl, where it resulting in high positive charge that employ from firm electrostatic forces over negatively charged coagulated matter. So a study shows the acidic condition intensifies the coagulation agent in the natural coagulant, resulting in greater coagulation activity and turbidity removal. On the other hand, the effectiveness started to drop rapidly when the pH is increased to neutral and moderate alkaline pH, except for BPPS coagulant. The water look opaque and less flock after the settling process due to the pH increment in the BPJ and BPPS plus BPJ coagulant sample. Okay, so this could be due to the charges produced by inulin from banana stem juice that act as a natural polymer, which helps in bridging and entrapping the microfloc to form a larger floc. Nonetheless, acidic medium showed the highest turbidity removal, where pH 2 was chosen as optimum pH for all coagulants. Okay, one of the important factors in achieving higher coagulant efficiency during coagulation flocculation process is the mixing speed. Okay, so continuous experiments for all coagulants were performed under optimum dosage and pH in order to investigate the effects of mixing speed condition on the turbidity removal. So figure 5 shows that 5 minutes of rapid mixings at 180 rpm, okay, and 20 minutes of slow mixing at 60 rpm attain the greatest turbidity removal for BPPS, BPJ, and then BPPS plus BPJ coagulant, which it can remove about 98.8, and then 97.9 and 99.1% of turbidity respectively. So the floc's growth are not significantly influenced by a lower mixing speed. Okay, in terms of the flock settlement, slow mixings of 60 rpm form a larger flock and settle more uniformly compared to slow mixings of 25 rpm and 40 rpm. So in this study, slow rpm was not to be considered on the flock formation properties. Okay, so this finding is also consistent. Okay, that the repulsive forces tend to stabilize the suspension and prevent the particle agglomeration. And last but not least, we have come to the conclusion. So as a conclusion, we can say that the turbidity removal from the river water using the banana peels and pith as natural coagulant demonstrate promising result and application in the water treatment. And then the high turbidity removal, which is up to 99%, was achieved by using banana peels and pith as dual coagulant, okay, which is BPPS and BPJ, at the 20 to 20 ratio milligram per liter dosage at pH 2, and then rapid mixing at 180 rpm 5 minutes, and then slow mixing at 60 rpm 20 minutes. The FTIR analysis of the coagulant showed that the presence of functional groups such as hydroxyl, OH group, and carboxylate, COO negative group, contributed to the whole coagulation process. And then the factors such as dosage, pH, and mixing speed actually played a very important role in the coagulation and flocculation process. Okay. And last but not least, the banana peel and pith coagulant, it can be claimed as a low-cost, environmental friendly, and also sustainable, okay, for the water treatment process. That's all from me. Thank you very much.